So that was adding and subtracting polynomials. We're going to talk about multiplying them together. So with multiplying, you can either have the multiplication symbol in between two parentheses, or directions can say multiply these together, or you can have nothing in between the parentheses if they're just back to back like this. That was a terrible parenthesis algebra. Like this is a much better parenthesis. So that's how you just know how to do it. There are two methods I'm going to show you. FOIL is a pretty nice shortcut. However, it only works in some instances, and the other is area method, which I know that you've seen before. Let's take a look. So that was adding and subtracting polynomials. Now we're going to go ahead and multiply polynomials. We know that this is going to be multiplication of polynomials because we have our two parentheses right here. There's no symbol between them, so that just tells us, hey, multiplication. Now, you have probably seen the area method before. We're definitely going to go over that in our next example. This, however, we're going to do something new called FOIL. And it's a really handy shortcut for multiplying together two binomials like this. Notice they don't even need to have the same like terms. We have a 2x and a 4x. Those are like terms. But there's no other like term for the negative 2, and there's no other like term for the 3x squared. That's perfectly okay. With FOIL, we can do that. Let's give an example of what FOIL does. We're going to start with the front. So I'm going to multiply the two front terms of the binomial together. Well, 3 times 4 is going to be 12. X squared times x is going to be x to the third. Well, after the front, I need the outer. So I'm going to do the terms on the outside, this 3x squared and this negative 2. Well, negative 2 times 3 is going to be negative 6. And then x squared times, there's nothing else there, so the x squared just comes on down. Now we want the inner terms. So I'm going to do these two. They're on the inside of the two binomials. So that's just going to be 2 times 4. That's just going to be 8. X times x is x squared. Last but definitely not least, we want the last two terms. So positive 2 times negative 2 is negative 4. X times is no x there, so just x. This is almost in standard form. We just need to combine some things together. These two middle terms that both have an x squared can be combined. So this stays the same. The minus 4x stays the same. And the middle two terms just combine to be positive 2x squared. And we FOILed it. We're good to go. It's a handy little shortcut. Now, where FOIL falls apart is if your chopped cheese gets too heavy and like it just falls to the foil. Yeah, you're still getting the bad jokes, even though this is remote learning, folks. Where FOIL falls apart is if you have something like this. The reason being, we'll have a lot more than 4 terms being created here. FOIL works where you have a binomial times a binomial. In this example, we have a trinomial, tri because it has 3, times a binomial, bi because it has 2. For this, we need to use the area method, which you have seen before again and again and again and again and again. So we're just going to run through it real quick.
Let's make that an n. It's all the same thing. Cool.
Now, what you might notice happens sometimes with area method is like terms are diagonal across from each other. You've seen it before. For instance, these two both have an n squared to them. These both have an n. The n to the third up here in this corner doesn't have any like terms. Neither does the negative 42 down in this corner. Sometimes it happens. If it doesn't happen, that's all right. You didn't do anything wrong. It just happened to be a problem set up where it wasn't going to happen. So let's just combine everything. We'll have 56n to the third. I'm going to combine these two that are on the highlighted yellow diagonal. So that's going to end up being negative 97n squared. Again, that was from the highlighted yellow part. And then we have the green diagonal, so that's going to end up being positive 91n. That I got from combining the two greens. And last but not least, the minus 42 comes on down. We know this is in standard form because we start off with something to the third power. Then it drops one power, it drops another here. Remember, there can be an invisible 1 right here. And then this doesn't have a power. Since all of the exponents are in decreasing order, we're good to go. We are done. So you might wonder if this is the correct answer, and it's kind of a pain in the butt to check. So you don't want to go through and do the whole process again. Well, thankfully, technology has provided a way for us to do that. What I'm going to do is I'm going to graph out the original product of the trinomial times the binomial. Then I'm also going to graph out the product itself, and I'm going to see if they're the same graph. If they are, cool, I was totally right. And I'm going to do that using Desmos. Some of you may have already used Desmos before. It's a really handy graphing calculator. Also, I have it under one of our resources, Desmos Graphing Calculator. You just click it, and there's the link. So let's see how we would go about doing this. I'm going to move this over so I can easily see stuff, and I'm just going to type in 8x. I'm going to use x instead of n, so the graphing calculator knows what the heck to do with it. Cool. And it graphs. It's a weird looking graph, but it graphs. Then I'm going to type in this down here, 56n to the x to the third minus 97x squared plus 91x minus 42. Oh, silly me. And if our multiplication was right, they should be the exact same graph. And notice, when I zoom in here, the blue graph has kind of taken over the red graph. I can click this button and the blue graph goes away. Click it again, it comes back. And you might think, wait, I only see one graph, what's going on here? That's right. You're only seeing one graph simply because they're overlapping each other completely. And that's what we want. If you're checking and you have one graph, cool, you did it right. If you're checking and you get two graphs, something funny happened, go back and check that math. By the way, this also works for addition. You can plug your two addition or subtraction problems up here. Find the sum or difference, plug it in here. If they're the same thing, you're good to go. Nice, easy check. Okay, you've seen how to multiply polynomials, and you've seen a great way on how to check them using Desmos. That's really straightforward. You can also, of course, use any graphing calculator that you may have, or if you prefer using another online grapher, go for it. It really helps out to check, and it's really quick. Plus, it really helps with those delta math problems if you check them first before you hit submit. That way, maybe you catch a mistake before you have to start an entirely new problem again. Give those 5 a shot, do your best with them, and then complete the rest of the assignment. Go for it, folks.